In order to mitigate climate change, we need to eliminate our carbon emissions by 2050 and reduce them to half of today's values by the mid to late 2030s. This means we need to act now and act at scale and keep ramping up over the next 20 years if we're going to stand any chance of mitigating the worst consequences of climate change. Moving to 100% renewable power generation sources offers a solution, and this includes a complete transition into our storage, redistribution and use of power, and a complete decarbonisation of heavy industry. There exists vastly more capacity than we require from solar and wind power generation technologies. The cost of solar power in the sunniest places in the world is already much cheaper than the cost of producing electricity from traditional sources, and it's going to keep driving down in price over the next 10 to 20 years. The inevitable implication of this is that by the 2030s, the cost of producing electricity from solar will be cheaper than the operational cost of traditional power sources. Every year we produce photovoltaic modules, that's the unit that absorbs sunlight and produces electricity, with about 150 gigawatts capacity. That compares to, for instance, a coal-fired power station might be 2 gigawatts. So that sounds like quite a lot, but actually to meet the demands for all power generation, we need to ramp that up to 20 to 60 times and be producing between 1 to 3 terawatts of photovoltaic modules per annum. Although there's plenty of capacity for further cost reductions through scaling, the efficiency of today's technology is reaching a fundamental ceiling of around 25%. This means that 75 to 80% of the solar energy is actually wasted. In Oxford, we've discovered that a new material called perovskites, as a solid solar absorber layer, can generate electricity extremely efficiently. We process or coat the silicon with a layer of perovskite, and in this so-called tandem cell we can produce a fundamentally higher efficiency. Today we've already demonstrated close to 30% efficiency, and we have a roadmap to get up to 40% efficiency over the next 10 years, and then even up towards 50% over a longer timescale. Solar and renewable energy generation technologies more broadly are at a very early stage of their development, both technological and in terms of scale. My message ahead of COP26 is that with the appropriate amount of investment, person effort and ambition to scale, these technologies can mitigate climate change and deliver a cheaper power generation source for our future generations.